Hello viewers. Today we will be solving the IB Math EA November 2024 paper 2 question number 9. You will be getting the solutions for the first 8 questions of this paper along with the other solved questions from the other past papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on the topics. I'm Nilanjana Sanyal. I'm an online IB Math EHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question. The maximum mark is 7. The sum of the first n terms of a geometric sequence is given by Sn equal to sigma r equal to 0 to n minus 1, 5 times log of c to the base 2 whole raised to the power of r. So, but his question is, given that Sn converges, find the range of possible values of C. Okay, since Sn converges, that means the common ratio will be between -1 and +1. So, subpart E, first of all, we have to find the common ratio. First of all, let us take the n value as 1. So, it is S1. Sigma r equal to 0 to n minus 1, that means 1 minus 1. And 5 times log of c to the base 2 whole raised to the power of r. Okay. R equal to 0 to 1 minus 1 is also 0. So, this will be having a single term, which will be r's value is 0. So, it is 5 times log c to the base 2 whole raised to the power of 0. And anything raised to the power of 0 is 1. So, it is 5 times 1, which is 5. And we know S1 is equal to U1. First term. Always. Okay. Now coming to S2, which will be U1 plus U2. So this is R equal to 0. Now n's value is 2. So it will be 2 minus 1. There will be 2 terms. 5 log c to the base 2 whole raised to the power of r. So this is 5 times, first of all, r's value is 0 plus 5 times sigma. So it is plus 5 times log c to the base 2 raised to the power of 1. 2 minus 1 is 1. Okay. So there will be 2 terms. And this one is U1. We know this one is 5. And this is 5 times log c to the base 2. So this is 1. U1. So this has to be U2 because S2 is equal to U1 plus U2. Okay. So this has to be U2. Therefore, common ratio R is equal to U2 over U1, which is 5 log c to the base 2 over 5, which is equal to log c to the base 2. Okay. And c is not equal to 1 because if c is equal to 1, then r equal to, okay, let me write then r equal to log 1 to the base 2, which will be equal to 0. And if the common ratio is equal to 0, then you can have a non-zero first term, but all the other terms of the sequence will be equal to 0. So we cannot have the c value equal to 0. C value equal to 1. Okay. And now since the Sn is converging, the r value, since Sn converges, therefore R's value should be between -1 and +1. Okay. Which implies in place of R, I'll be writing this expression. -1 is less than log C to the base 2 is less than +1. Okay. So this gives us, I'm converting this to exponential form. So, okay, let me write these two inequalities separately. You can write it together. I am writing this for some students who may get confused. So, if we convert this logarithmic form to exponential form, what happens? We find this to be C is greater than 2 to the power of -1, or C is greater than half. Okay. And also, if I take this inequality separately, I get this expression. C is less than 2 to the power of 1, or C is less than 2. Okay. So this one is giving us the range of values for C. C is greater than half, but is less than 2, and C is not equal to 1. Okay. So this is the answer for the part A. Part B, in the case where C is equal to 1.5, find the least value of n such that the absolute value of S infinity minus Sn is less than 0.1. Okay, so this is the part B. S infinity minus Sn is less than 0.1. So let us find the S infinity, and C is equal to 1.5. So S infinity expression is U1 over 1 minus R. So U1 was equal to 5. U1 is 5. Okay. And R was equal to log C to the base 2, and C is having the value of 1.5. So it will be 1 minus log 1.5 to the base 2. Okay. So this is the S infinity expression. And coming to Sn, Sn will be equal to summation R equal to 0 to n minus 1, 5 times. Okay, let me just show you the expression once more. It is Sn equal to sigma summation R equal to 0 to n minus 1, 5 times log of C to the base 2 whole raised to the power of R. Okay. Log of C, in place of C, I'll be writing 1.5 to the base 2 raised to the power of R. And this can be expanded. So it will be, for the first term, we know that it is 5 plus it is 5 log 1.5 to the base 2, because we have seen the expansion. I'm not writing in detail. We have seen the expansion of S2, so it is this. Third term will be 5 times log C to the base 2 raised to the power of 2. So this will be just continuing. Okay. And so on, plus 5 times. The last term will be having the R's value as n minus 1. So 5 times log of 1.5 to the base 2 raised to the power of n minus 1. Okay. So this is a paper 2 question, but you are having 3 dots over here. So I cannot just input this expression in the calculator with the 3 dots. It will not work. So I have to simplify this part, I have to use some formula to get some expression. And this is a geometric series, so I can take out 5. You do not have to, but I am just taking out 5. So it is 1 plus log 1.5 to the base 2 plus log 1.5 to the base 2 whole square, and so on, plus log of 1.5 to the base 2 raised to the power of n minus 1. Okay. And this is again a geometric series with the first term as 1 and the common ratio as log of 1.5 to the base 2. And so r equal to, let me write r equal to log of 1.5 to the base 2 and u1 is equal to 1. So it will be, you can take, which formula will you be taking? Will you be taking this u1 times 1 minus r to the power of n over 1 minus r, or you will be taking u1 times r to the power of n minus 1 over r minus 1. Both will be giving you the same answer, but usually when r's value is less than 1, we take this formula, and when r is more than 1, we use this formula. And this is paper 2, you will be able to find the value of log of 1.5 to the base 2. And you will be seeing that it is less than 1. But if you do not want to waste that time, log of 2 to the base 2 is 1. Okay, and log of 1 to the base 2 is 0. So log of 1.5 to the base 2 will be between 0 and 1. So it will be a fraction, it will be less than 1. Okay. So therefore, this is equal to 1 times, we are using this expression, this formula rather, 1 times 1 minus log of 1.5 to the base 2. And how many terms are there? There are n number of terms. Do not take the number of terms as n minus 1, because there is this term also 1, which is log of 1.5 to the base 2 raised to the power of 0. Okay, so the terms are from 0, the power 0 to power n minus 1. So there are n number of terms present. Okay. Over 1 minus log of 1.5 to the base 2. So this is Sn. Therefore, S infinity is this one, 5 over 1 minus log 1.5 to the base 2 minus 5 times 1 is 5. So 5 times 1 minus log of 1.5 to the base 2 raised to the power of n divided by 1 minus log of 1.5 to the base 2. This is the absolute value. This will be less than 0.1. Okay. And I'll be using the graphs because you cannot solve an inequality using nsolve. So let's go for the graphs. Okay. Okay. And I'm seeing that we are having log of 1.5 to the base 2 over here, and over here. So I can first of all save this. Let me save this. It is base 2 and this is 1.5. Okay, and let me name it as A. Enter. Okay. If you want to verify, you just press A and see, now it is in bold, and enter, you will be getting the same value. Okay. So in place of log of 1.5 to the base 2, I'll be writing A. So, first of all, it is the absolute value. Therefore, this is this. And it is 5 over 1 minus e minus 5 times 1 minus e raised to the power of, since we are graphing, we cannot use n, it will be x. Okay, and fine. And denominator is 1 minus e. Yes. And let us graph this. Okay. And I need the 0.1 also. Enter. I am seeing the y value, the intersection point is between 0 and 1. So let me change the window settings. Window settings. Let me take x min as 0, -1, because I want to see the y axis. I'm not sure where will the intersection point lie. Let me take this as 20. And this one I can take as -1 to see the x-axis. And this one as +1. Okay, better, much better. And now it should be less than 0.1. So the graph will be below this horizontal line. So we have to find the coordinates of the point of intersection. Therefore, analyze graph and then intersection. See, it is x value is 8.94, correct to 3 significant figures, or I can say 8.9357, anything. But n value will be an integer. So this is the smallest value. So the integer, first integer which is more than this is 9. So the least n value, possible n value will be equal to 9. So n is equal to, let me write 8.9357. Okay. Using GDC graphs, n equal to 8.9357. Therefore, least, what was the syntax? Least value of n, least value of n is equal to 9. Okay. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will really help me a lot. Your liking and sharing and subscribing will be telling the YouTube that my video is worth watching, so my video's reach will be increasing. It will be motivating me, so it will be really helping me. We meet again very soon in our next session. We will be solving question number 10 of the same paper. Till then, bye.